Okay, just like on the last examples, we're going to want to start by factoring. Remember, a difference of cubes is factorable, and we factor that as x minus 1 times x squared plus x plus 1. And then we decompose this. Now, this one's a bit different because if you remember on the last examples, they were all linear factors. We had back here, we have, these are all linear factors. They may be to powers, but the x's themselves are not to any power. Here, this one was able to factor down into an x and an x minus 1. On this one, we had x minus 3 and x minus 2. So those were all linear factors. Here, I can only have an x minus 1, and then I have this x squared plus x plus 1, which won't factor any further, but it's not a linear factor. So when we split this up, I have a over x minus 1, but I can't just do b over the x squared plus x plus 1. I have to use a bx plus c. That's going to make that x would cancel with the x squared in the bottom and make that a linear factor, and this is how I go about doing that. So similar, but because it's not a linear factor, I have to do it in this other kind of way. Again, I multiply by the common denominator. 3x minus 5 is equal to a times the quantity x squared plus x plus 1. And then this bx plus c gets multiplied by x minus 1. Now, just like before, well, like not just like before, because I can't just let x equal 1 here and make things go away. It won't make things 0. I'd still have problems. I'd still have x's and numbers and things like that. Oh, no, I can let x equal 1, but I can't just let x equal 0. So I can let x equal 1, and I can plug some stuff in, and I get 3 times 1 minus 5. And on this side, I get a times, and it's going to be 1 plus 1 plus 1. And then this part over here, that does become 0. So left side, negative 2 equals 3a. And so a is equal to negative 2/3. That one's nice. I can do that. That still works. But I can't, there's not another one that I can do that with. I can't let x equal 0 and make something drop out. I can't do anything else where I just plug a number in. So what I'm going to do then is I'm going to go ahead and do a little distribution. And the distribution is going to be over here on the right side. So I'm going to have, just go ahead and distribute that a through. And just do the double distribution here with the bx plus c and the x minus 1. Bx squared minus bx plus cx minus c. Now I'm going to kind of group some stuff here. I'm going to group the x squareds together. I'm also going to group just the x terms together. And then any constants together. And so when I do that, and then I'll take and simplify down a little bit here, do a little bit of factoring in these groups. I can factor out an x squared. I can factor out an x. And I can, and the last one I'm just going to leave alone. There's nothing it has in common. So I have this. And what happens here is I look at this, and the x squared here has to match with the x squared on the other side, on the left side. There is no x squared, so what that tells me is that a plus b has to equal 0. The x here has to match with the x over here. So that tells me that a minus b plus c is equal to 3. And then the constant on the right side has to match with the constant on the left side. So that means that a minus c has to equal -5. Now, once I've got that, then I can go through and find the different things that I am looking for. And I could do a lot of different things here. It kind of depends on how I want to go about this. I could probably plug in the a and make it work. Or I can just look at these two and say, if I do some elimination with this and combine those, I get 2a plus c is equal to 3. And then I can go through and plug in my a. I don't know why I did that. I just decided that I wanted to go through and do a little bit extra algebra. -4/3 plus c is equal to 3. Add that 4/3 across. C is equal to 13/3. And then I'm just going to come back to here. -2/3 plus b is equal to 0. That means b has to equal 2/3. There's a and b and c. And then I can rewrite my answer as 3x minus 5 over x cubed minus 1 equal to, and it's going to look kind of ugly for a second. Where I plug those things in. We don't want fractions within fractions, no compound fractions. So what I will end up doing is multiplying the top and the bottom by 3. And getting this for an answer.